Hi guys and welcome to another Devcast. Today it will be about Machina. There was a slight delay in Machina Devcast. I think it was a couple of months, maybe even half a year since my last Machina Devcast, and it was a single Machina Devcast that I actually did because Machina is still in pre-alpha even today. And I mainly use it to catch bugs in my node-based framework that I use for Dash as well. So it's always good to have multiple projects to basically do a feasibility test of some API or some framework, and I'm using the same node-based framework for Machina as well as for Dash, and there are the same expression evaluations, same rendering of the GUI, and all that stuff. Machina is, to be honest, is it's way more complicated than Dash because there is a millions of operations running in Machina in a lot of cases, whereas in Dash there are like tens of operations in a frame. So Machina needs to be a lot more optimized, and which is good for Dash as well because I port the optimizations when it comes to, for example, expression, execution, and so on back to Dash. And also there are features in Machina that are not really needed in Dash, and vice versa, obviously. But for example, in Machina you need to have, for example, index access to attributes because you can have attributes on vertices. So you need to be able in expression evaluation evaluate basically a vertex attribute on a specific index inside the mesh, whereas in Dash you have only attribute as itself. So also Machina is not asynchronous; it just executes in a single call and generates the procedural geo, and there is no preview for it. It's all is automatic, so you need to I'm still trying to figure out how to work in it inside editor, because sometimes you basically override your stuff. For example, if you are using a mesh filter as an input and Machina is writing to it, so basically it will there will be a cycling reference and so on, but that's not the topic of today's video. Today I want to talk about two features that I added uh, while I was merging these two framework, or the latest updates from the Dash back to Machina, and these are targeters and deformers. I also want to mention that while implementing these, even though these are not applicable to Dash, I did implement a few features in Machina, like controller variable overrides and stuff like that, that will be ported back to Dash. So for those of you that only use Dash and for some reason watch this video, there are some updates from this Machina update that will come to Dash as well. So let's start to talk about Machina in general and these two new features. I have some objects here. For this is from object from Bitgam. Uh, it's a cemetery asset. I'm not really sure which one, but check it out on Asset Store, and publisher is Bitgam. We have a lot of bought assets. I actually have this asset bought for myself as well as the company has it. And I want to, as I mentioned in the previous video, a lot of the times you don't really want to generate the procedural geometry for some reason. For example, you don't have artists that are familiar with tools like Houdini or familiar with Machina. So to model this type of fence, or how should I call it, it's way easier for them to do in Blender on 3D Studio. But I still want to add some procedurality into it by modifying it procedurally. You can take assets that were created as a static mesh, and then you can modify it as well. So for example, I have this scene with a small cemetery, uh, and it looks kind of like uniform, and I will use Machina here to basically add more randomness into it. So I have this graph on my test object. It's called Deformer. It's an asset graph. So if I modify this, all the assets that have this graph will be modified as well. And what I do here, I take a mesh input. Let's render it out as well. I take this mesh input. So this is the asset actually from the bitgam, and then I bend it in. Let me skip this one. I bend it in. Now you can see this. The green one was the original. I bend it in Y direction, and I also bend in X direction. And I'm using a random function with a variable that basically specifies the min and max, or the max bending in that axis. And then I just output it. I use null nodes. For those of you that are familiar with Houdini, null nodes are used as a single output, because if I want to skip this one, for example, the null is not changed. So I always have a single null node as an output, so I don't really delete it. Uh, let me let's modify these a bit more so we see these bends, and let's do it like this. So this is a very simple graph that will bend your assets. We can also modify the seeds here, so the bending will be different for all the seeds. As you know, Machina is seeded, so the two generations on a graph with the same seeds will be same. So what I want to do now is apply it to this scene. What you could do is have all these assets with Machina controller and the deformer Machina graph there. But this is where the targeters, one of the new features, comes into place, and it's a new component that will basically retarget this controller. So Machina controller checks if there is a targeter component on the game object, and if there is, it will apply its output to all the targets specified by the targeter. So it will not try to apply. As you can see, there is no mesh on this particular game object. It will basically go over all these targets and apply this deformer. So let's just play it and let's see what we get. Well, there are two issues, obviously, right here. We did really do an extreme when it comes to bending, and the other issue that is obvious is that our crosses basically were substituted. Let's go back and try to solve that. Let's go to the graph. Let's solve the substitution. The Unity Mesh input node has a new property, which is basically it will skip explicit setting of the object, and it will use the mesh filter on, or the mesh on the target itself. There is a bit of a problem at the moment, because we basically targeted the mesh on this, and it was already a mesh generated by the Machina, but doesn't really matter. We just want this on the game scene. So let's run it and let's see what we get. Okay, so the substitution is working. The bending is a bit extreme. But let it be like this, because I want to show you one more thing, and that is that we don't really want to bend the stone under the fence, because it shouldn't be really bent. I mean, stones don't bend, only the fence itself, the iron part, should bend. So let's fix it. I already fixed it, and I will show you how. I want to add this here and this input right here. So what this does, Basically, we are using a box as a volume. It's a simple primitive, and this box is transformed just to so we can change the stuff we want to bend. And let's recalculate this. Okay, so we want only to bend the affected vertices. So we see which vertices should be affected. Okay. I don't really want to. Just need to do this one and. Oh, I know what's the problem. The problem is that we already have a modified geo, so this is it. My bad. So, because we already modified the mesh before when we set it to be used as an input as well. So we had a modified dash mesh that was then used as an input. No, not dash Machina mesh that was then used to as an input for Machina, so it was bent twice. So now we have the original geo, and let me show you. We have this box that specifies which vertices we specify a volume or a group based on volume called affect, and now these bends, let's bend it a bit more again. Now these bends will only affect these vertices. As you can see, it doesn't affect the stone anymore. If I, for example, if I went higher, you see that only the vertices outside, because I have inverted the selection, outside of the box are bended. So we just want to bend and here as well. We just want to bend the steel. Okay, and now we want some small. We will use this as an input. Again, we have twice bended geo, but doesn't really matter for this because this is just a test object. What it will do on the scene. Let's play it, and as you can see, now we have these perfectly regular stones, and we also have the randomization in our scene that we needed. We can play with it a bit more, but this makes the scene more non-uniform and more, let's say, fancy. So that's it. And now I want to talk about deformers. So let's go to a different object, this one, and open the Machina editor. So what we have here is this this input, this mesh, and the output is this. What it does, it basically bends or just rotates a part of the mesh. This is not doable using bending, because bending will work differently. You can rotate that uh, in bending. And what we use here is the deform node, which basically takes as a mesh input. Then it takes uh, the deformer in its rest state, its default state, and the deformer in its modified state, which is this rotated one, and it will apply it into the geometry. So if I just rotate this, you see that the geo is applied or modified, deformed based on this deformer and a few parameters. Uh, like which vertices will be affected. is based on the distance from vertices of the deformer. So if I just set it to 1, you can see that it will basically modify almost all of them. So we could work with 1 and specify a group name if we basically have a group of all these vertices that we want to deform. It will work similarly to the bend node. But there are, as with many procedural artwork frameworks, there are a lot of like ways how to approach a problem and how to basically work it or create the output. So we have this deformer, and we can modify it. As you can see, this will not rotate. If we wanted to rotate that, what we need to do is specify a box deformer that I will show you, because we would need these vertices to have a different constraint than these vertices for it to actually rotate. But this is for simple modification. This is okay. There are a few other other properties that I'm not going to really talk about, but you can play with that. Just keep in mind that if you have a geo which is not closed, this geo is not closed. Obviously, it uses flat shading, so there are double vertices, and using these deformers on a non-closed geo may result in open geometry. So what this does is basically force the deformer to a fixed constraint. So basically, it will just modify it by the fixed amount the constraint is modified. Actually, so there will be no deformation solving. It will be pretty simple, and this will result in the vertices that were at the same position before the deformation will be at the same position after the deformation, because there is a fixed constraint. So let me show you the final graph that I want to show, and that's using multiple deformers. We have this. Let me enable the info. We have this input of the, again, from Bitgam cemetery fence, and we use deformer on part of the mesh. Again, this is a line deformer. It will not execute because I have this as a cached geo, so I need to turn that off. So now it's not cached, it will deform again. And I want to show you here, if I execute this one, let's cache this because we are not going to change it. And that's the thing that I wanted to show in the previous as well. If you want a more fine deformation, we need to use box. And box, I will just transform it. I generate a box using a box node. I will transform it where I actually need it on the mesh. And since the mesh look like this, I need it. Okay, I need it somewhere around here. And that is my rest state for the deformer, and I have a transformed state for the deformer, which will deform it, and all these vertices will have a different constraint as this one, so it will actually rotate, whereas here it doesn't rotate because they have a single constraint, so it's basically just an offset. And now I can modify this, and it will rotate. I can also specify the rotation using a variable. So let's just like band This is obvious. I'm just throwing it out here. Now you have these are errors because as we were typing the variable, it was not found. I will fix this. This is a pre-alpha stuff. It's not really an error because there was no ban variable and so on. So now if we have this band here, we can modify it using variables. I can also modify it using an instance variables because these are graph variables, and I can have an instance variable which is a separate component called Machina variables controller, and it will be an instance variable. Using a bound graph, this is basically instance variable because the graph is on the instance as well. But if you, for example, had this graph, all the variables inside it would be same for all the instances using this graph. So if you want to override it on the instance, you need to have a Machina variable controller, and it will be an instance variable. This is something that will come back to Dash as well, because there is no instance variables in Dash. There are only graph variables and global variables. So, and the instance variables have a priority over graph variables. So when there is the expression evaluation is running and the resolving on variables is going on, first it will try to look for instance variables, then for graph variables. So we have this working, and I want to just showcase as a bit more. If I add this here, basically I have an edit node which is vertex edit node, so I have a specified bunch of vertices uh, which then can be edited using this node, and I'm editing the deformer, and since I'm editing the deformer, it will also edit the underlying geometry that the deformer is applied to. So this is so I want to show this to show you that deformer is not just for rotating objects. You can basically deform the object in any way you want to, and it will deform the underlying geo. I will have a separate devcast on deformers and more advanced deformers later. I just wanted to show you this uh, work I did during holidays, and some of you were asking about Machina, when it is going to be public and so on. If you want to test it out, just send me a message. I will see what I can do. At the moment it's still private, it's still pre-alpha. There is a lot of minds lying around that when I'm showing this demo, I sometimes I'm really on my toes just not to step up on a mine, for example, as I did with the input, and it took me a few seconds to know what's going on, that the input was the same as the output and there was a cyclic bending going on. So hopefully this is something that you guys will be interested in. Some of you wrote that I'm basically writing my own Houdini. Yes, I'm big fan of Houdini, and I'm big fan of procedural geometry. I did a lot of procedural geo in my demo scene days, so I like to play with it, and I like to know how things work. That's why I like Houdini, because you always know how things work in Houdini. I know I can use something like Houdini engine for this, but as many of you know, Houdini is quite expensive for us to use in our company, because we have a huge company, and the second drawback of Houdini engine at the moment is that Houdini engine only runs in editor, so you can do this modification only in editor, whereas Machina will run on runtime as well. So I don't really need to generate these modified meshes as a geo at editor time. I can basically modify it on once I start the game and have my modified level working with less resources. You can also export this. There is one of the new features, and have it as an have it as a external modified mesh, no problem. if you want to use Machina in generating geometry in editor, no problem. But I am targeting runtime as well. If there are any questions, if there is any feedback, if you like it, basically any feedback is welcome. Even if you don't like it, just tell me what's you don't like, what's that specific thing you don't like, because not liking a procedural framework as a whole is not really constructive. But who knows? Let me know, and thanks for watching.